You know, light is everywhere. It powers our world, it grows our food, and it's literally filling the screen you're looking at right now. But have you ever stopped to think about it? The light from the sun, the glow from your phone, and say the flicker of a firefly, they're all created in fundamentally different ways. So today we're going to dive into the surprising science behind what light actually is and how it's made. Okay, let's start with the big one, the original source, the sun. It's basically a colossal nuclear furnace, and it floods our planet with an absolutely unimaginable amount of energy, all in the form of light. And then, of course, there's the light we've created, a whole world of artificial glow, right? From the light bulb hanging over your head to the very screen you're watching this on. But then there's this, and this is where it gets really strange. Light can come from life itself. I mean, deep in the ocean, even in our own backyards, living things create their own glow. They carry their own little biological lanterns around. So a star, a screen, an insect, they all produce light, that much is obvious. But is it all the same kind of light? That's the real mystery we're going to unravel today. What is the fundamental difference between the raw, brute power of a star and the delicate, silent glow of a firefly? To figure that out, we first need to make one simple but absolutely crucial distinction. And it really just boils down to this. Some things, like the sun or a light bulb, create their own light. We call them luminous. Pretty much everything else, from the moon in the sky down to the chair you're sitting on, is non-luminous. We can only see them because they're bouncing light from a luminous source into our eyes. For this journey, we're focusing on the creators. Now, once we're just looking at that group of light creators, things get really, really interesting. It turns out there are two fundamentally different recipes for making light. One is hot, and the other one is cold. And right here, this slide, this is the key to the whole mystery. On one side, you've got incandescence. This is light that's basically just a side effect of something getting incredibly hot. Think of a blacksmith pulling a glowing sword from a forge. On the other side, you have luminescence, light made through all sorts of other clever ways that don't involve heat. And this is where things get really cool. So first, let's talk about the hot stuff. Incandescence is really the brute force method of making light. You just take something, like that tiny tungsten filament inside an old-school light bulb, and you run enough electricity through it to heat it up until it glows. It's simple for sure, but as you're about to see, it's not very clever. And here's the crazy part. Look at that. A staggering 90% of the electrical energy that we pump into one of those old incandescent bulbs is completely wasted. It's just radiated away as heat, or what we'll soon learn is infrared light. Only a tiny 10% actually becomes the visible light that we want. It's honestly more of a space heater than a light bulb. So this brings us to the much smarter, much more efficient alternative, luminescence. It's often called cold light, and for a good reason. It creates photons of light without wasting all that energy as heat. Instead of using brute force temperature, it uses clever chemistry or biology or even electricity in a different way. You know, once you stop relying on just getting things super hot, a whole new world of fascinating light-making methods just opens right up. So let's take a quick tour. Okay, think about a glow stick. This is a perfect example of something called chemiluminescence. That's light from a chemical reaction. When you bend that plastic tube, you're actually breaking a little glass vial that's floating inside. This lets two separate chemicals mix, and bam! The energy that's released by their reaction is given off directly as visible light. No heat needed. It's just pure chemical glow. And it turns out nature is the absolute master of this trick. Bioluminescence is basically just chemiluminescence that's been perfected inside a living creature. Fireflies, for example, use a special enzyme to create their light, and it's for a very simple purpose: to attract a mate, maybe lure in some prey, or even to scare off a predator. It's an incredibly efficient, life-or-death kind of chemical glow. Okay, so we've seen that light can be made hot, or it can be made cold. But what is the light itself? I mean, whether it's coming from a blazing star or a tiny bug, what is actually traveling from that source to our eyes? Well, fundamentally, light is a wave. And a wave is a really special thing in physics. It's a disturbance that moves energy from one place to another without actually moving any stuff along with it. The classic example is a ripple in a pond, right? The energy moves across the water, but the water molecules themselves mostly just bob up and down in place. Now, every wave has a couple of key properties. There's its wavelength, which is just the distance from one peak to the next, and its frequency, which is how many of those peaks pass by a certain point every second.
And here's the one rule you really need to remember. The shorter the wavelength, the higher the frequency, and the higher the energy.
And here's the mind-blowing part. Whether it's a super high-energy wave or a low-energy one, whether it's from a star or a glow stick, all light travels at the exact same unbelievable speed. 300,000 kilometers per second. That is fast enough to circle the entire Earth more than 7 times in a single second. It is the universe's ultimate speed limit. So, we've covered how light is made and what it is, but now we get to the final piece of the puzzle, and trust me, it's a big one. It turns out that what we call light is just a tiny, tiny fraction of what's really out there. You see that white light from the sun or a light bulb? It isn't really white at all. It's actually a mashup of all the colors of the rainbow. Everything from the longer, lower energy waves of red light, all the way to the shorter, higher energy waves of violet light. This right here, this is our entire visible world. But is that it? Is this tiny little rainbow of colors the only kind of light there is? Well, the answer is a huge no. Our visible spectrum, the world we see, is just a tiny little island in this vast ocean of energy called the electromagnetic spectrum. It includes everything from super low energy radio waves with wavelengths that can be meters long, all the way up to incredibly high energy gamma rays with wavelengths smaller than a single atom. And now it all connects. Remember that 90% wasted energy from the old light bulb? Well, that's just infrared light, the invisible wave right next to red on the spectrum that we feel as heat. And you know, a fluorescent light works by creating invisible ultraviolet light on the other side of the spectrum, which then hits a special coating and makes it glow with visible light. The invisible world is all around us, and it's powering the visible one. Which leaves us with one last, really fascinating thought. Our eyes evolved to see this one specific, tiny sliver of reality. So if this is the world we can perceive, just imagine the universe that's out there, completely invisible to us, flying past us at the speed of light at this very second. What else are we missing?